We are starting with first module of strength of material, which is introduction to the concept of stresses. Before going to the content of this module, we should know the some basic unit, which are 1 meter is equal to 10 raised to 3 mm. If we have to convert meter to mm, we have to multiply the meter by 10 raised to 3. If we have to convert mm to meter, we have to multiply it by 10 raised to minus 3. 1 kilonewton is equal to 10 raised to 3 Newton. 1 megapascal is equal to Newton per mm square. 1 pascal is equal to Newton per meter square. 1 megapascal is equal to 10 raised to 6 Pascal. 1 gigapascal is equal to 10 raised to 9 Pascal. 1 gigapascal is equal to 10 raised to 3 megapascal. This is important unit conversion because sometimes the Young's modulus is given in gigapascal. We have to convert it to megapascal to solve the problem. 1 kilonewton per mm square is equal to 10 raised to 3 Newton per mm square. Now, stress. It is the internal resisting force per unit area developed inside the material when the external force is applied. We can say stress is equal to pressure upon area or force upon area. The unit of stress is Newton per mm square or Newton per meter square. Type of stresses. Tensile stresses. When the body is under the pulling action, it is uh, it is said to be in the it is said to be as a tensile stress. Compressive stresses. Pushing. If the body is under the pushing action, it is compressive stress. The sign convention of tensile stress is positive and sign convention of the compressive stress is negative. Strain. Strain is a unitless quantity. It is change in length upon original length. Lateral strain. Lateral strain is equal to change in lateral dimension upon original dimension. Volumetric strain. It is a change in volume upon original volume. Now the next point is Hooke's law. Within the elastic limit, the stress is directly proportional to the strain. Stress and strain is directly proportional within the elastic limit. It is the Hooke's law. Stress upon strain is equal to E. E is the Young's modulus or modulus of elasticity. Unit of modulus of elasticity is Newton per mm square. Uh, Change in length. Now some numerical ask the change in length of the material. So the formula of change in length we can derive from the Young's modulus, stress upon strain. So we know stress is equal to pressure upon area and strain is equal to change in length upon original length. Putting these two values in this formula, so we get change in length is equal to PL upon AE. Okay, or change in length we can say this P upon A is converted into stress. So change in length is also be calculated by stress into length by modulus of elasticity, or change in length is equal to strain into L length. Now the shear stress. Shear stress is equal to shear force upon area. Shear force is parallel to the direction of body. uh, Shear force is in Newton and area is in mm square. So the unit of shear stress is also Newton per mm square. Modulus of rigidity. Modulus of rigidity is equal to shear stress upon shear strain. Bulk modulus is volumetric strain stress upon volumetric strain. The formula of bulk modulus is P upon delta V upon V. It is also be written as EV, volumetric strain. Okay. Now the relation between Young's modulus, bulk modulus, and modulus of rigidity. E is equal to 3k in bracket 1 minus 2 mu. It is the first relation. Second relation is E is equal to 2g 1 in bracket 1 plus mu. It is second relation. E is equal to 9 kg upon 3k plus g. It is the third relation. Now the Poisson ratio. Mu is known as Poisson's ratio. it is EL upon E, lateral strain upon normal strain. Okay. Let's see this problem now. In this problem, one pressure P is unknown. We have to determine P and the total elongation of the circular bar with the cross-sectional area 200 mm square. Okay, so the length is given in meters, so we have to convert this all length in mm first while calculating. Okay, so considering the condition of equilibrium, the sign convention is left side going force is negative and right side going is positive. So minus 50 plus P minus 20 plus 50 is equal to 0. So the P is equal to 20 kilonewton right side. Okay, so the value of P is 20 kilonewton. So we write here 20 kilonewton. Now consider the section A, B. Here is 50 kilonewton and here is 20 kilonewton. So we have to add 30 kilonewton to the right side. We can't add the force at left side, so it is in the equilibrium. Total force is 50 kilonewton. Okay, now the next section B, C. We give 30 kilonewton to B, so we take back 30 kilonewton from B. Now forget about this 20 because this 20 is balanced by this 30 kilonewton, so we only put 30 kilonewton, only take 30 kilonewton back from this P side. Okay, now C is loaded with 20 kilonewton. So if we have to put this system in equilibrium, we have to add here 50 kilonewton. So that 50 kilonewton minus 20 kilonewton is equal to 30 kilonewton, because the 50 kilonewton is going in this direction and 20 kilonewton is going in this direction. So it will subtract because this is positive, this is negative. So remaining resultant is 30 kilonewton. So the BC section is under 30 kilonewton. Now the CD, we give 50 kilonewton to the C, so we take back 50 kilonewton from C and 50 kilonewton at D is already present. So this is 50 kilonewton. Okay, now the change in length of AB is equal to PL upon AE. Okay, so delta L AB is equal to pressure at AB is equal to 50 into 10 raised to 3. Because this is in kilonewton, we have to convert it into Newton. So 50 into 10 raised to 3 into length of this is 1 meter. So we have to put length in meter. So 1 meter, we have to put length in mm. So this is in meter, we have to convert it into mm. So 1 meter is equal to 1000 mm. Okay, now area is 200 mm square and E is 2 into 10 raised to 5 Newton per mm square. It is in megapascal. Okay, we did not need to convert this. Okay, now so delta L BC is equal to 30 into 10 raised to 3 into length 1000 upon area 200 into E, 2 into 10 raised to 5. L delta L CT is equal to 50 into 10 raised to 3 into length is equal to 1000 mm and area is 200 mm square and E is 2 into 10 raised to 5 Newton per mm square. So that's it. By calculating this 3 value, we will get total delta L is equal to total change in length of this bar is delta L AB plus delta L EC plus delta L CD. If they ask what is the maximum stress in this question, so the maximum stress is equal to maximum pressure or force is treated equal in this types of question. So the maximum pressure is 50. So 50 into 10 raised to 3 upon area is 200 mm square, so this is Newton per mm square. By calculating this you will get the value of maximum stress. So thank you.